Welcome, ladies and gentlemen, to this video lecture. Okay, so we have now seen how to compute integrals of products of odd powers of sine and cosine. So now we will move to even powers of sine and cosine. So this configuration turns out to be a little bit trickier. So the idea here is we will use the following three trigonometric identities. So the cosine squared of x, that is equal to 1 plus the cosine of 2x over 2. The sine squared of x is 1 minus the cosine 2x over 2. And the double angle identity for the sine, 2x is equal to 2 sine x cosine x. Okay, and the idea is we want to rewrite if n and m are natural numbers, we want to rewrite expressions of the following form: sine x cosine sine x to the 2m cosine x to the 2n. We want to somehow rewrite this into some polynomial expression, and then what will happen is we will either get something that looks like this, so something cosine 2x, and here we have some polynomial expression in sine 2x, so perhaps with some powers here on the sine, or what we want is the other way around, sine of 2x, and here we have some polynomial expression of the cosine 2x, perhaps with some powers and some terms there. So that is the idea. And why do we want to do that? Always keep in mind, what are we trying to get to? We're trying to get to something that looks like the result in a chain rule. So the derivative of sine is cosine. So if you apply the chain rule to some polynomial of sine 2x, you end up with the chain rule to get this extra factor of the 2 cosine 2x, or with the sine 2x. So that is the idea. So these ones tend to become a little bit trickier because there tends to be no algorithm to be able to see exactly which identities you should apply. Okay, let's take a look at an example. We want to compute the following integral. So let's define it as the integral from 0 to pi over 4 of 4 cosine to the 4x sine squared x dx. And we see here we have our cosine and sine both to even powers. Okay, so first thing what we will do is we will first manipulate our integrand. So let's write it like so. Okay. And let us take 2 cosines and 2 sines. Let's factor that out. And what are we left with? We are left with a 4 cosine squared x, and here we've got a cosine x sine x squared. So you see here, if we multiply that out, we get back exactly what we had at the beginning. Okay, and now we apply our identities that we had before. So let us apply this identity to this factor, so that is cosine squared x, and this then becomes sine of 2x over 2 squared. Okay, and let us apply one of our identities there, so this one. So let us apply that identity, so that becomes 1 plus the cosine of x over 2 squared. In fact, let's move the square up there so you can see what is. No. I am mistaken. No, there should be no square there, of course. Sine 2x over 2 squared. Okay. And now let us see what we get. Okay, let us multiply out this first factor, so that becomes 2 plus 2, and sorry, that there should be 2x in there, 2 times 2 cosine 2x, and here we've got this 1 over 4, let's write it over there, sine squared 2x. Okay, let's multiply that out, 1 over 4, 2 times sine squared 2x plus, and I'm going to swap the 2 around, that is 2 times 1 over 4 sine squared 2x multiplied with cosine 2x. And now we see here this term is fine, because here we have some polynomial expression in sine 2x multiplied with its derivative, so that this term is fine. Now we need to take care of this term over here. And what are we going to do? We're going to use this identity to take care of that term. Okay, so let's see what we can do there. This becomes a half, and that becomes 1 minus cosine 2x over 2, or 1 minus cosine 2x over 2 plus, and now this term, 1 over 2 sine squared 2x cosine 2x. Okay, and let's multiply out this term here, and let's see what we get. That becomes 1 over 4 minus 1 over 4 cosine 2x plus 1 over 2 sine squared 2x cosine 2x. Okay, and now we see here every term is something that is easy to integrate. So here we've got a constant, here we've got a cosine, which when we integrate that is something to do with a sine, so that is easy. And here we have some polynomial expression multiplied with the derivative of what we are applying this polynomial expression to. So this cosine 2x is the derivative, or is related to the derivative of sine 2x. So here we can use the chain rule in reverse again. So our integral is equal to the integral from 0 to we had pi over 4, and we can now write in our integrand 1 over 4 cosine 4x plus a half sine 2x squared cosine 2x dx. And this then evaluates to, that is 1 over 4x. Our integral here, that becomes minus sine, I made a mistake, because it was sine squared 2x, that actually should be a 4x, so 4 cosine 4x, there we go. Sorry about that. Okay, if we integrate that, that becomes minus 4x over 16, because if we take this derivative of sine gives us the cosine, and by the chain rule we end up with this factor of 4 here, which will cancel with one of the 4's that is a factor of 16. So that is fine. And finally here we see we have this polynomial expression in terms of sine 2x, and that is the derivative of sine 2x, or is related to the derivative of sine 2x. That will be the sine 2x cubed. We want a factor of 3 there, and we want an extra factor for the 2 there that will come out through the chain rule. So you see here, if we apply the derivative towards x on here, our 3 will cancel with that 3, and by the chain rule we'll end up with this factor, what will it be, cosine 2x, and then again by the chain rule the 2 there, and this 2 will cancel with that 2, and we're left with that 2 that we had as the factor there. So here we have our last term, and here we can now substitute in our bounds, and if we do that, that becomes 1 over 4 pi over 4 minus sine pi over 4 times 4 sine pi over 16, 1 over 12 sine pi over 2, and that is cubed, and now minus 0 minus 1 over 4 times 0 minus 0, sine of 0 is 0, and similarly here as well, minus 0. So all these cancel, and what we're left with is what we have there, pi over 16 minus sine of pi, which I believe is 0. So if you look at the graph of sine, goes from 0 to 2 pi. Here at pi is 0, so this term is also 0, and pi over 2 over there is 1. 1 cubed is 1, so plus a 12th, so plus a 12th. So finally, pi over 16 plus 1 over 12 is what I get. Okay, and that is it for this example. I will see you in the next one.